So first thing, we're gonna start by pressure in solids. If we see both pictures, we can see that Stickman is trying to pin two different objects to his wall. First, he started by pinning a bowling pin. He is exerting a specific amount of force, but this force doesn't seem enough in order to make an effect, which is pinning the bowling pin to the wall. While if we see that the same amount of force exerted on the nail was enough in order for the nail to be pinned to the wall. So here we're talking about how the force is creating an effect, and this effect is called the pressure, which should be enough to either pin or doesn't pin an object to Stickman's wall. So we need to compare or to see why this effect, the pressure, was successful when we used a nail and wasn't successful when we used a bowling pin. So if we compare the surface area in contact, so this is the surface area in contact with the wall of the bowling pin, and that's the surface area in contact of the nail with the wall. If we compare both of them, we can see how the bowling pin has a larger surface area than the nail. And it seems as if surface area and pressure, or the effect, have a relationship. But we can see that when we have a large surface area, the pressure seems to be less, while when we have a small surface area, the pressure seems to be more. This proves that both pressure and surface area have a relationship that is inversely proportional. We say the smaller the surface area, like the nail, then the greater the pressure. And this can give us the relationship between pressure, surface area, and force, which states that pressure is equal to the force, how much force you're exerting, and how much this force is being distributed on a surface area. Pressure has a unit that depends on the Newton force and the surface area meters squared. So the pressure will have a unit of Newton per meter squared. We can rearrange the formula in this triangle. But in fact, this effect was previously discovered by Blaise Pascal, who was a French scientist. And so the unit was shifted after that to Pascal, after his last name. So the pressure unit, SI unit, is Newton per meter squared, or it's Pascal. These are some direct applications, very simple direct applications. In the first question, we want to find the pressure. So it will be force divided by area, and it gives you 5 Pascal. In the second one, we want to get the area. So it's force divided by pressure. It will give you 6 meter per second, squared. And in the last question, we want to get the force. So it's P times A. It will be 460 Newton. Remember to keep on placing the correct unit next to the correct variable. But unfortunately, the questions aren't always easy as the direct application. Sometimes they don't give you the surface area A. Instead, they give you a geometrical regular object, and they ask you to find the pressure. So first, you need to find the area by applying the rule, this mathematical rule to get the surface area. And then you can proceed to get whatever other variable you need in the question. Okay? And sometimes they give you the unit in centimeters squared. It's better to always convert it to the SI unit. It's by dividing it by 10,000. Okay? Now, how can force, pressure, how can it be useful in our daily life? Here are some examples that shows how important pressure and its effect is on our daily life useful things. The studs on your football boot, as you can see, they have a small surface area, so that your weight that is exerted downward will be distributed on a smaller surface area. And we know that the smaller the surface area, the more the pressure. And so it gives you a better grip to the ground. Same thing applies to the ski, but this time the ski has a larger surface area. So your weight is actually distributed on a larger surface area. And a larger surface area means a lower pressure, and so you won't sink into the snow. Third example is the blades of the knife. So the blades of the knife are extremely small, that the pressure that you're exerting, or the force that you're exerting, has a higher pressure, so it can cut easily and go through the material like food and other stuff. Last example is the wall foundation. So the wall are made with a large surface area, horizontal area beneath it, in order for the weight of the wall to be distributed on a larger surface area. Hence the pressure will be reduced, or it will be less, and so the wall won't sink further if there is any problem with the wall.